Soil is the biologically active, porous medium that has developed in the uppermost layer of the Earth's crust. Soil is one of the principal substrata of life on Earth, serving as a reservoir of water and nutrients, as a medium for the filtration and breakdown of injurious waste, and as a participant in the cycling of carbon and other elements through the global ecosystem. It has evolved through weathering processes driven by biological, climatic, geological, and topographic influences. Since the rise of agriculture and forestry in the 8th millennium BCE, there has also arisen by necessity a practical awareness of soils and their management. In the 18th and 19th centuries, the Industrial Revolution brought increasing pressure on soil to produce raw materials demanded by commerce, while the development of quantitative science offered new opportunities for improved soil management. The study of soil as a separate scientific discipline began about the same time with systematic investigations of substances that enhance plant growth. This initial intersect has been expanded to an understanding of soils as complex, dynamic, biogeochemical systems that are vital to the life cycles of terrestrial vegetation and soil inhabiting organisms, and by extension to the human race as well. Definition of soil. There have been several conceptions held about soil in the historic past. This has led to several definitions of soil by different people at various times. Some of the several definitions range from very simple definitions to very professional definitions, such as the following. Soil is a thin layer of material on the earth's surface in which plants have their roots. It is made up of many things, such as weathered rock and decayed plant and animal matter. Soil is formed over a long period of time. Soil is the unconsolidated mineral or organic material on the immediate surface of the earth that serves as a natural medium for the growth of plants. The unconsolidated mineral or organic matter on the surface of the earth that has been subjected to and shows effects of genetic and environmental factors of climate, including water and temperature effects, and macro and microorganisms conditioned by relief acting on parent material over a period of time. A product soil differs from the material from which it is derived in many physical, chemical, biological, and morphological properties and characteristics. Soil is a natural body comprised of solids like minerals and organic matter, liquid and gases that occur on the land surface, occupy space, and is characterized by one or both of the following: horizons or layers that are distinguishable from the initial material as a result of additions, losses, transfers, and transformations of energy and matter, or the ability to support rooted plants in a natural environment. Soil, in terms of its morphological characteristics, is defined as unconsolidated surface material forming natural bodies made up of mineral and organic materials and the living matter within them. Soil is a dynamic entity with material continually and simultaneously added, removed, and transformed. Its formation begins with a parent material derived from either the underlying rock or material transported from somewhere else to its present site. It is mainly the combined effects of climate and living matter that convert a material to a soil. For example, in temperate rainy environments, moisture and dense vegetation may lead to deep, richly organic soils. In deserts, with the lack of moisture and subsequent vegetation, soils may be thin and remain highly mineral. Human disturbances such as dwellings, agricultural practices, grave sites, and garbage dumps may also affect soils, giving them other unique characteristics. Soil, in terms of its morphological characteristics, is defined as unconsolidated surface material forming natural bodies made up of mineral and organic materials and the living matter within them. Soil is a dynamic entity with material continually and simultaneously added, removed, transformed. Its formation begins with a parent material derived from either the underlying rock or material transported from somewhere else to its present site. Pedology. In Greek, the word pedon means soil and logos means study. Pedology is the study of soils in their natural environment. It is one of the two main branches of soil science, the other being edaphology. Pedology deals with pedogenesis, soil morphology, and soil classification. Pedologists are interested in the practical applications of a good understanding of pedogenesis processes, the evolution and functioning of soils, like interpreting its environmental history and predicting consequences of changes in land use. While agronomists understand the cultivated soil is a complex medium, often resulting from several thousands of years of evolution. Important pedological concepts include complexity in soil genesis is more common than simplicity. Soils lie at the interface of Earth's atmosphere, biosphere, hydrosphere, and lithosphere. Therefore, a thorough understanding of soils requires some knowledge of meteorology, climatology, ecology, biology, hydrology, geomorphology, geology, and many other earth sciences and natural sciences. 5 major external factors of formation: climate, organisms, relief, parent material, and time, and several smaller, less identifiable ones drive pedogenic processes and create soil patterns. Characteristics of soils and soil landscapes: example, the number, shapes, arrangements of soil bodies, each of which is characterized on the basis of soil horizons, degree of internal homogeneity, slope, aspect, landscape, position, age, and other properties and relationships can be observed and measured. Pedogenic soil forming processes act to both create and destroy order, anisotrophy within soils. These processes can proceed simultaneously. The resulting soil profile reflects the balance of these processes, present and past. The geological principle of uniformitarianism applies to soils, that is, pedogenic processes active in soils today have been operating for long periods of time back to the time of appearance of organisms on the land surface. These processes do, however, have varying degrees of expression and intensity over space and time. There are very few old soils in a geological sense because they can be destroyed or buried by geological events or modified by shifts in climate, by virtue of their vulnerable position at the surface of the earth. Little of the soil continuum dates back beyond the tertiary period, and most soils and land surfaces are no older than the Pleistocene epoch. However, preserved and lithified soils, paleosols, are an almost ubiquitous feature in terrestrial environments throughout most of the geologic time. Since they record evidence of ancient climatic change, they present immense utility in understanding climate evolution throughout geologic history. Knowledge and understanding of these genesis of a soil is important in its classification and mapping. Soil classification systems cannot be based entirely on perceptions of genesis. However, because genetic processes are seldom observed and because pedogenic processes change over time, knowledge of soil genesis is imperative and basic to soil use and management. Human influence on or adjustments to the factors and processes of soil formation can best be controlled and planned using knowledge about soil genesis. Soils are natural clay factories. Clay includes both clay mineral and structures and particles less than 2 micromillimeter in diameter. Shales worldwide are to a considerable extent simply soil clays that have been formed in the pedosphere and eroded and deposited in the ocean basins to become lithified at a later date. Edaphology. Edaphology is one of the two main divisions of soil science, the other being pedology. Edaphology is concerned with the influence of soils on living things, particularly plants. Edaphology includes the study of how soil influences humankind's use of land for plant growth as well as man's overall use of the land. In Greek, edaphos means ground, logy means study. General subfields within edaphology are agricultural soil science, also known by the term agrology, and environmental soil science. Agricultural soil science. Agricultural soil science is the application of soil chemistry, physics, and biology dealing with the production of crops. In terms of soil chemistry, it places particular emphasis on plant nutrients of importance to farming and horticulture, especially with regard to soil fertility and fertilizer components. Physical edaphology is strongly associated with crop irrigation and drainage. Soil husbandry is a strong tradition within agricultural soil science. Beyond preventing soil erosion and degradation in cropland, soil husbandry seeks to sustain the agricultural soil resource through the use of soil conditioners and cover crops. Environmental soil science. Environmental soil science studies our interaction with the pedosphere on beyond crop production. Fundamental and applied aspects of the field addresses Vadose zone functions, septic drain field site assessment and function, land treatment of wastewater, storm water, erosion control, soil contamination with metals and pesticides, remediation of contaminated soils, restoration of wetlands, degradation, environmental nutrient management. It also studies soil in the context of land use, planning, global warming, and acid rain. Soil as a three-dimensional natural body. Soil is not only a support for vegetation, but it is also the pedosphere, the locus of numerous interactions between climate, water, air, temperature, soil life, microorganisms, plants, animals, and its residues. The mineral material of the original and added rock and its position in the landscape. During its formation and genesis, the soil profile slowly deepens and develops characteristic layers called horizons, while a steady state balance is approached. Soil horizons. Soils differ widely in their properties because of geologic and climatic variation over distance and time. Even a simple property such as the soil thickness can range from a few centimeters to many meters depending on the intensity and duration of weathering, episodes of soil deposition and erosion, and the patterns of landscape evolution. Nevertheless, in spite of this variability, soils have a unique structural characteristic that distinguishes them from mere earth materials and serves as a basis for their classification. A vertical sequence of layers produced by the combined actions of percolating water and living organisms. These layers are called horizons, and the full vertical sequence of horizons constitute the soil profile. Soil horizons are defined by features that reflect soil forming processes. For instance, the uppermost soil layer, not including surface litter, is termed the A horizon. This is a weathered layer that contains an accumulation of humus, decomposed, dark colored, carbon rich matter, and microbial biomass that is mixed with small grain minerals to form aggregate structures. Below A lies the B horizon. In mature soils, this layer is characterized by an accumulation of clay, small particles less than 0.002 millimeter in diameter, that has either been deposited out of percolating waters or precipitated by chemical processes involving dissolved products of weathering. Clay endows B horizons with an array of diverse structural features, blocks, columns and prisms formed from small clay particles that can be linked together in various configurations as the horizon evolves. Below the A and B horizon is the C horizon, a zone of little or no humus accumulation or soil structure development. The C horizon is often composed of unconsolidated parent material from which the A and B horizons have formed. It lacks the characteristic features of the A and B horizons and may be either relatively unweathered or deeply weathered. At some depth below the A, B and C horizons lies consolidated rock which make the R horizon. These simple letter designations are supplemented in two ways. First, two additional horizons are defined. Litter and decomposed organic matter, for example, plant and animal remains that typically lie exposed on the land surface above the A horizon are given the designation O horizon, whereas the layer immediately below the A horizon that has been extensively leached, that is, slowly washed of certain contents by the action of percolating water, is given the separate designation E horizon or the zone of alluviations. The development of E horizon is favored by high rainfall and sandy parent material, two factors that help to ensure extensive water percolation. The solid particles lost through leaching are deposited in the B horizon, which then can be regarded as a zone of alluviation. The second enhancement to soil horizon nomenclature is the use of lower case suffixes to designate special features that are important to soil development. The most common of these suffixes are applied to B horizons. They are denoted in small letters as indicated in the table. Summary of base symbols for surface horizon along with subhorizons. Letter codes indicating major horizons. O. Organic horizon containing litter and decomposed organic matter. A. Mineral horizon darkened by humus accumulation. E. Mineral horizon lighter in color than A or O horizon and depleted in clay minerals. AB or EB transitional horizon more like A or E than B. BA or BE transitional horizon more like B than A or E. B. Accumulated clay and humus below the A or E horizon. BC or CB transitional horizon from B to C. C. Unconsolidated earth material below the A or B horizon. R. Consolidated rock. Suffix letters, codes indicating special features of major horizons. A highly decomposed organic matter. B. Buried horizon. C. Concretions of hard nodules, iron, aluminium, manganese or titanium. E. Organic matter of intermediate decomposition. F. Frozen soil. G. Grey color with strong mottling and poor drainage. H. Accumulation of organic matter. I. Slightly decomposed organic matter. K. Accumulation of carbonate. M. Cementation or induration. N. Accumulation of sodium. O. Accumulation of oxides of iron and aluminium. P. Flowing or other anthropogenic disturbance. Q. Accumulation of silica. R. Weathered or soft bed rock. S. Accumulation of metal oxides and organic matter. T. Accumulation of clay. V. Plinthite, hard, iron-enriched subsoil material. W. Development of color or structure. X. Fragipan character, high density, brittle. Y. Accumulation of gypsum. Z. Accumulation of salts. The combined A, E, B horizon sequence is called the solum or floor in Latin. The solum is the true seat of soil forming processes and is the principal habitat for soil organisms. Pedons and polypedons. Soils are the natural elements of weathered landscapes whose properties may vary spatially. For scientific study, however, it is useful to think of soils as unions of modules known as pedons. A pedon is the smallest element of the landscape that can be called soil. Its depth limit is the somewhat arbitrary boundary between the soil and not soil, example, bedrock. Its lateral dimensions must be large enough to permit a study of any horizon present in general, an area from 1 to 10 square meters, taking into account that a horizon may be variable in thickness or even discontinuous. Wherever horizons are cyclic and recur at intervals of 2 to 7 meters, the pedon includes one half the cycle. Thus, each pedon includes the range of horizon variability that occurs within small areas. Wherever the cycle is less than 2 meters or wherever all horizons are continuous and of uniform thickness, the pedon has an area of 1 square meter. Soils are encountered on the landscape as groups of similar pedons called polypedons that contain sufficient area to qualify as a taxonomic unit. Polypedons are bounded from below by knot soil and laterally by pedons of dissimilar characteristics. Differences between soil profile and soil pedon. In a simple way, we can consider a pedon as a three-dimensional structure, minimum 1 square meter surface up to 10 square meter, that contain all the properties of the studied soil. The soil profile is defined as a vertical section of the soil from the ground surface downwards to where the soil meets the underlying rock. In this way, a soil profile could be one of the vertical face of a pedon. Soil horizons are the different layers in an horizontal disposition of a soil profile with different properties and characteristics as color, texture, mineral content, etc. Summary: soil is the biologically active porous medium that has developed in the uppermost layer of the earth's crust. Soil is one of the principal substrata of life on earth, serving as a reservoir of water and nutrients, as a medium for the filtration and breakdown of injurious wastes, and as a participant in the cycling of carbon and other elements through the global ecosystem. It has evolved through weathering processes driven by biological, climatic, geologic and topographic influences. There have been several definitions of soil. One of the comprehensive definition is: soil is a natural body comprised of solids like minerals and organic matter, liquid and gases that occurs on the land surface, occupies space and is characterized by one or both of the following horizons or layers that are distinguishable from the initial material as a result of additions, losses, transfers and transformations of energy and matter, or the ability to support rooted plants in a natural environment. Pedology is the study of soils in their natural environment. Edaphology is concerned with the influence of soils on living things, particularly plants. General subfields within edaphology are agricultural soil science or agrology and environmental soil science. Soil is not only a support for vegetation, but it is also the pedosphere, the locus of numerous interactions between climate like water, air, temperature, soil life and its residues, and the mineral material of the original and added rock and its position in the landscape. Soil is a three-dimensional vertical sequence of layers produced by the combined actions of percolating waters and living organisms. These layers are called horizons, and the full vertical sequence of horizons constitutes the soil profile. Horizons are coded by different letters like A, B, C. Pedon is the smallest element of landscape that can be called the soil. Its depth limit is somewhat arbitrary boundary between soil and non-soil.